All right, so this is update number 4 for the Arduino project for the 7.3 Power Stroke. And um, today I'm just making a quick update on the PTO, the 6-bolt PTO cover that I gotta make for the thermocouple. So this is just what it looks like in general here. So here are the 6 bolts for the PTO bolt holes. I'm gonna right now in the truck. There's some hex bolts, but I want to use some Allens. Uh, so just yeah, just gonna be some socket cap screws. Here is the NPT, 1/8 inch NPT for the thermocouple. And as you can see here, I'm machining a sort of built-in thermal well that I'm gonna fill with a dielectric. Just a heat conductor paste for to transfer uh, the heat from the oil inside the transmission to the thermocouple without exposing the thermocouple to the harsh conditions inside the transmission. So I'm doing this with a 3D toolpath. It's just a parallel, and I want it to be quite nice. So I have a 1 thou spacing in between each toolpath. It's only 34 minutes. So yeah, all the cam is done. I can do a simulation here. I still need some tweaks, obviously. I did this just to get a rough idea. I still have to see my tool clearances with the holders and everything to make sure I don't crash the machine. But more or less, this is what is going to happen. All I want so yeah, the setup is setup number 1. It does this side, it does the holes and the facing and everything. And then on the other side, it just does a pocket and the 3D toolpath, of course. And for this feature here, the NPT thread, I just want the CNC. I'm going to do a third setup, and all I want it is to just give me a center point, uh, or not even, and I'm just going to do it all by hand uh, on the drill press or something. So here I'll show you the setup, simulate. So we're on the other side now. So here's the facing pass. It's a 1.5 inch overlap. And then here I'm center drilling for the holes. There's a peg drill for the guide hole. Here's the actual hole size. Counter bore, no, that's the contour with a 1/2 inch end mill. This guy. Taking really small passes just to maintain my tools. I'm not doing it really for efficiency, just the tools stay in good shape. Don't put too much wear on them. I'm on the other side now. In the facing, now that's going to do the contour, same as before. So doing 50 thou overlaps, I think. So here's the 2D pocket. That goes right above the thermal well. And then, yeah, see this I have to fix, but uh, yeah, here's the pocket. So here's the thermal well starting to develop. I don't want that because it's supposed to be a chamfer there. So I still have some fine tuning to do, as you can see, but uh, the essence of the program is there, you can say. So I'm skipping through. The path is quite heavy. And by the way, I'm only able to do this if I can get my DNC software going with my mini mill because uh, this is going to be lots and lots of lines of code, and the classic host control doesn't have enough memory for this whole path. So at least I'm assuming, and because I've had trouble with this before in the past. So all I might do is just keep this square and just have it all straight lines and no fancy fillets and everything. I don't think it's going to make that much of a difference for the heat conductivity, considering this is made out of aluminum. Uh, but I mean, we'll see. Uh, it'll be a lot easier to just keep it straight, but for now I'm just going to keep it like this. It's a very easy modification to make. So yeah, that's it for the cam. And then my next setup, I'm just gonna have it in the vise, kind of vertical like this, and I'm just gonna poke a hole. Maybe even drill the hole, but might just do it by hand. Anyways, that's it for update number 4. Talk about, I think this is my last update actually. Yeah, thanks. Bye.